title of my talk is, as was said, it's channeling the functional designer within you. So so who am I? As you heard, my name is Damian Reeves. I'm a senior software developer slash vice president at Morgan Stanley, and I'm also a contributor to an open source project by that a project that's been open sourced by Morgan Stanley under the umbrella of the Financial Services Open Source Initiative, known as FINOS. It's a project named Morpher that's all about functional domain modeling. Um, I'm a husband of one incredible wife, father of four fantastic children. We call the Fantastic Four. I'm a first-time conference speaker, and I'm a functional programming compiler and programming language enthusiast. I did .NET from around 2001 to 2017, and I've been doing Scala development for the last 3.5 years. Um, but can I be honest? In my mind, I thought I could whip together this awesome talk with somewhat obscure or mainstream pop culture references, right? Can you picture it? You heard the title, "Channel the Functional Designer Within You." That's what I envisioned in my mind. Um, it would be awesome. My coworkers, my wife, my children, they'd all celebrate my Scala and presentation mastery, and it'd kind of be like this. Um, just soak that in and soak it in. uh, But alas, I come down to earth a little bit after I saw some of the presentations yesterday, like the Scala JS one. Great job, Kit. Um, so you're going to get this instead. Uh, Channel the functional designer within you, and let's set the stage. The reason you're getting this is I work for a bank, right? And this means I work for a large enterprise. And large enterprises, they behave and they act a certain way. First of all, large enterprises, they have a lot of developers. There are a large amount of developers in a company like Morgan Stanley. Um, Enterprises are different, and technologies change, but some facts remain across all enterprises. Um, Take some notes here if you ever want to work for a bank or a big enterprise. You will be tasked to maintain a legacy system. It is guaranteed that you will be tasked to maintain a legacy system. Um, you will be part of a rewrite to modernize a legacy system. So at some point, and I've been through many of these, someone's going to say, all right, this thing is old. It's not keeping up with technology. Let's write it again. And the other unfortunate fact is your modern system, it will become the legacy within some time period. Um, and you will also, and this is a key part of the talk I want to give today, you will work with someone who has been working on all iterations of that system for at least 15 to 20 years. I've worked in financial services for a while, and I've it's been amazing how I've come across people with tenures from 20, 15, some 30, 35 years. I've come across people who work in, programming APL and COBOL and all these systems that we know as legacy now. And you know what? Trying to teach new programming paradigms to these individuals can be difficult. So I asked the question, how will you react? Equipped with such insight, we must react, and one must make some decisions. You can choose to become a hired gun, right? You can hop around, build your resume, yeah, greenfield or bust, if you will. Or you can choose to ride the waves, right? Changes happen. It's going to happen no matter what you do. Um, and technology comes and then technology goes, right? So there'll be fads, there'll be all these things. Systems change, and hopefully they evolve. They don't just get blown up. They don't just get shipped and put out to pasture. Um, and of course, our reactions could be we can complain, right? I'm sure some of us have dealt with these people where everything sucks, right? Everything's no good. Then we can be those people who just ignore and become ambivalent. This is fine. The system with uh, inheritance tree that goes on 10 levels deep, no problem. we can't we can only unit test if we run the entire suite. We got to connect to all the databases, we got to hit all the backend systems. That's how we unit test. Yeah, fine, sure, no problem. Or you could be a change agent, right? As Gandhi said, be the change that you want to see in the world. So quick agenda. uh, let's talk about the problem. I'm going to outline um, as best as I can some of the problems I've seen in working in enterprise and how functional programming and functional design can help. Oh, I think I already gave away. Um, what's the solution? Well, at least the one covered in this talk, apart from the fact that I spelt this wrong and missed it. Uh, this, there's this one little trick, and here's the hint. As I said before, it's functional design. Um, you want some code? I'll show you some code. We'll go through a summary that includes the takeaways. So, the problem: enterprise systems. Um, enterprise systems are big. Um, Next, enterprise management is risk averse. And finally, enterprise developers, not finally, but enterprise developers tend to be resistant to change. And I'll tell you what I've come across, and object oriented programming has been the paradigm embraced by enterprise developers. No matter where you go, the paradigm that most people adhere to is OOP. And as popular as functional programming has become, we've had this vast amount of hybrid languages like Scala. My background before I came to Scala was actually in C sharp, and then afterwards I moved over to F sharp, because I would write distributed systems. Well, before even distributed systems, I was writing desktop software that was multi-threaded, and I ran into issues where we had to manage race conditions and we had to manage multiple threads, and immediately I saw that immutability was something to be desired, not change in state, because mutable shared mutable state is your enemy, whether it's on a desktop application or if it's in a distributed world. So, but doing all this in object oriented programming, while it's possible, it's difficult. And that's why we've seen the advent and the increase of both languages like Scala, languages like F sharp that are hybrid, functional and object oriented. And we've seen other classically object oriented languages such as C sharp and Java, and others. They've started to embrace functional aspects. So I went on for a little bit, but I want to set the stage. And since I do work for an enterprise, I would love to be able to show you some of the code that I ran across and has been problematic, but I think I would be violating some NDAs. I would maybe be embarrassing some people. And let's use your imagination. This problem is by no. Let's outline the problem, right? Here's one issue that I've seen. You need to model a business process, and this isn't quite what I've dealt with, but it summarizes it to a degree. And oftentimes in the modeling of the business process, I join a team. We want to have business processes, and there's a common structure. Files need to be processed. The process usually includes reading some business events, reading some files, grab some reference data. And as I currently work on the accounting portion of the bank, we want to produce some accounting journals. Lots of terms might not necessarily all be familiar to you, but if we look at this a little bit, you can imagine. Here's one way you might see such a system, and I've left out a lot, but to a degree, this is actually a cleaned up version of some of what I've seen. You notice the abstract class, and we got a little bit of generics in here, and we've got configuration. What's actually happening here is that abstract class points to something that you will see even amongst Scala code bases, that a lot of object oriented enterprise developers, they will lean and fall back on inheritance. Inheritance is a tool to that's in the tool belt. And while inheritance is something that many of us learned in school or picked up when we learned programming and object-oriented principles, inheritance is not something that is the key to long-term maintainable software, not in the classic way, at least. Um, so uh, because we've advanced in some way and things have progressed, we've got something, and I'm going to use a term. Um, uh, this thing is dependency injection friendly, at least. And as much as we're using Scala, we were using Spring, and it's Spring. I don't know if it's just the firm I work at, but lots of enterprises love things like Spring. I'd love to be able to use Dice Stage, and maybe I will in the future. Um, so at worst, let's have something that can support dependency injection. So we have this composition root, if you know the term. It's a place where we can inject all our dependencies. And we say, all right, um, to meet our business requirements, we need to be able to grab some events from an event source. We need to get some account reference data. We need to get some trade information. We need to get some securities and more typos, of course. We need to store things in a journal store. Um, all that will happen, right? And it comes in, and all right, turns out that we've got actually like 50 of these business processes. So simple enough, inheritance to the rescue. So I'll do my bond accounting process for my bonds. I'll do my cash flow accounting process for my cash flows. I'll do my equity accounting process for my equity. And everything will be great because, of course, this design that I came up with, at some point, it's going to hold true as we have more products, more securities, more changes that come in from the users. And some of you are laughing because you know for a fact that is not the truth, that systems evolve, systems change. And what we've ran into is that going this approach where we have these large inheritance trees, where we've got 50 different modules that inherit from things, that you run into problems. One example is that, you've got this thing that may be due accounting, and you've got lots of who knows what, but it's lots of accounting specific things that are there. Code that no one's changed in years. But it turns out, and code that was made with certain assumptions, and it turns out that now someone decided that we're going to blow up all those assumptions, and now you've got 50 different business processes that when you change a top level structure in your inheritance tree, that it affects a lot of things. And this is where functional programming and there's other ways you can do things in object-oriented design, but functional programming can shine and help here. So here's some common problems. Common problems I've seen in the enterprise: object-oriented programming with deep inheritance graphs. It's a lesson we've learned now that inheritance is not your friend, right? Um, Not in the way that we may have been taught it. That, you know what, when it comes to writing enterprise software, it's not animals, it's not ducks and dogs and cats, and you're not making them speak. And that's not what happens. And unfortunately, many of us, that's how we learned how to code. The other thing that happens is, as great as dependency injection can be, as you have to plug things in, going back real quick, into a composition root like this accounting context, that oftentimes that this becomes a central problem place. It's something that I've ran into where suddenly the requirements change, and now, you know what? Not only do I need securities or trades or accounts, that now there's this. I need a pricing system. So now I've got to add a pricing service to this. And maybe this accounting context is something that we've got other inherited things that have this accounting context. So now what do I do? Now I need to, for this huge legacy system, I've got to add this property. I've got to push it down through many layers, and it becomes a real problem, right? The other thing I've seen is copy paste duplication, where because, yeah, I don't want to deal with these inheritance structures, I just copy some code. We get testability problems galore, and things written according, this is a big one, things written according to technical understanding rather than according to the business domain. Um, So ways to solve this, oh gosh, use the language of the domain, use types and functional design techniques, lean into composition. All right, so it's a lot of talking. I've been trying to get through the talk so that we can see some code, not the conclusion, but some code. Hopefully, things are large enough. So, what did we decide to do? Basically, given all those things, I want to talk a little bit about how functional design and using a system, like many of us have talked about, known as Zio, has helped my company. This is a bit of a personal story and a personal journey that this talk is. I introduced to my company Zio in a very interesting way, that we needed to compose these many processes, and we started to think about things in terms of how we wire things together and how we produced what it turned out were business flows. And our business flows were things that were easily modeled. And if you've ever looked at Zio, I'm going to hop into code. Maybe this is not something that you typically do during these talks. But if you look into Zio, for the faint of heart, there might be some things that you're not used to. But um, I just want to be sure you're seeing my code screen. Yes. Okay. Um, yeah. So if you look at Zio, you'll see that it has number one, these things that I like to think of in functional programming and in our as kind of channels. We see parametric polymorphism, and we see these R's and the E and the A. In addition to that, you see the minus, you see the plus, and you see the other pluses. And it's basically saying, if you look at them as channels, you've got an input channel, that's the requirements for Zio, uh, output channel, that is your errors, and your final value that you produce. And we used Zio, which has all the things that people have talked about, which is a way to represent all the academic things that we've talked about, state monads. You've got the either, you've got all those things encompassed in Zio. And we used it as the cornerstone of a design of something that's known as a flow. Um, and in that flow, we use the same mechanisms. And this is something that you can do, that I wanted to design how we can wire together a bunch of steps and produce these interesting flows. And what we did is, number one, I'll say, well, we started to outline what are the channels that we're dealing with. And dealing with, we're dealing with, of course, the state, which is our input state. We're dealing with output state. We're dealing with the environment. We're dealing with parameters, and we're dealing with errors and outputs. I didn't name them R, E, and A, but to help ease the pain for developers who weren't necessarily used to this style, we used concrete names. And the other thing that we went away from is we kind of wrapped around Zio and leaned in on Zio. And where Zio allows you to have inputs that are these requirements, which are kind of like your services that you might use, we wanted to have something where we can compose together a bunch of little processes and wire them together. So I will say from functional, part of the key of functional programming is that you are able to wire together really nice systems and really nice pieces. So whereas before we had to define a dependency structure, we didn't have to do that for the talk. And I'm gonna do a little programming. I thought I would go a different way before. So let's say, how does this look? So before, we had these business processes, and you can, thanks to the power of Zio and functional design, we're able to use composition, which is your friend, and we're able to basically define various flows. And I can, rather than using inheritance, now I can have my cash bond flow. Um, and I apologize if you didn't catch that term before, but we're able to, of course, if I import, um, we're able to import, sorry, we're able to do various things. I'm going to keep it real simple, but I'm able to produce value, and this would be like my business event. I don't know. Live coding is not the best thing, but let's imagine that I've got a component, and this is the first step in a flow. Um, um, let's keep it real simple. Um, and I can produce another step. Um, and if I was really, you know, going along, I would say, here's my bond event, right? And I might produce, let's just keep it simple for now. So I might produce, some new bond event. Let's, and let's say I'm getting a list of these bond events, right? Um, so that would be one step. But what I can do is I've now got this thing that's able to that that using many of the same design techniques that Zio embraces, I was able to, we wanted to be able to show how we can wire steps together. That's what these processes were before. So after having conversations, we started to talk about the problem in terms of the business. So a key thing that you want to do is that you, in your functional design, is think about how you're talking about problems. Before, we had all these very technical ways of discussing problems. But then it turns out that what we wanted to do was have various ways that teams could wire together these well-known steps, and that we can then just kind of put them together. So what this is actually a step that takes in some, it accepts anything, and I can have some other step that follows it. More to the point, what we actually have with our flows is we'll have, we had some sort of configuration. I'm keeping it very simple. Um, but you're able to define a step in terms of, you know, my initial step is maybe something that looks like a flow that I can say I define it from some function that's going to take in my input that's of type config, and I'm going to produce something. Um, I can produce maybe a list of bond events. Um, the interesting thing about this is while it doesn't seem like much going on, these blocks enabled us to do interesting things. One of the things that we do, and I really wish I could show the code, but we would, shouts to Leo, but and what he just presented, we would connect to Spark. And rather than this being some sort of list, we would, through Spark, we would have a data set of these bond events, and we would be able to, within this function, use all the power of Zio to get at what we need. I see my time ticking away. So let me just say that this is bond event.empty. And the next thing is uh, the next thing we did is we took these things, these different steps, and we put them into a catalog. Great thing about functional programming is you'll notice that what I just defined, this little unit of functionality, that is just a step, and You'll be able to explore the library afterwards. I'll show you the links. But it's just a step, and it's a step that has some sort of input, and it has some sort of output, and it can fail, and it can carry, you know, and it can have an environment. It's all the stuff you're used to with Zio, but you can wire together steps. So uh, I could go and I can do the next stage just to keep it simple. I can have another step that takes in a bond event, and maybe I want to, I don't know, I want to transform these list of bond events to something else. And what we typically do is we enrich these from some data source, and you end up with something like, um, you'll map it and you'll get an enriched bond event. Um, right. And of course, I'm able to then do just a simple thing where I can go from the initial to the next, and I can compose a pipeline. And build these stages. Of course, there's more to this. I will let me jump back into my presentation and just kind of close out from here. Um, all right. So in this time, um, what I hope to show was composition is a superpower. There for enterprise development, we've part of what I also wanted to say is that for enterprise development, that we've been leaning on inheritance. We've been leaning on object-oriented programming for a while, but through the power of composition, through the power of various functional programming techniques, we're able to compose great solutions. The other thing, parametric polymorphism is super cool. It's I did not really understand how quick a half an hour goes. I wanted to get into more details on how we were able to use that parametric composition to be able to create steps that compose really nicely, and to create a catalog of different things that, rather than using inheritance for sharing, we're able to make Lego blocks where we have components in our actual system where some components read files from Spark, some components read data from databases, and users are able just to pick the right component for the right data point that they use, and they just wire them together. And it's much easier than inheritance. So yeah, lead into things like these, uh, you know, and it allows you, these are superpowers that allow you, and gives you channels, channels of input that you can transform, that you can work with. um, and finally, I just want to say thanks to Functional Scala. Thanks to all of you for attending this talk. I know you're all waiting with bated breath to hear what John has to say after this. Thanks, John. There's a lot of code in the project, with which I will be pushing up, fairly this weekend, and it will be open to everyone to use. Thanks, Adam, who's been really great, with just providing support and guidance. And you too can be a functional design pro. That's it for me.